All right, good evening, graduate UNSY students. First, as a reminder, we are recording this session, and a copy is going to be made available for those who are unable to attend tonight. Next, for the format of our meeting, I'm going to start by introducing our guest, and then we're going to proceed into a Q&A discussion after his presentation. Afterwards, I'm also going to open up the session to a class-wide Q&A once I've asked a few just kind of interpretive questions, contextual questions. In the meantime, I do ask that you all mute your mics, save any questions you might have until the end, and that you use the hand raise icon to indicate when you do have a question during that period. I'll try to call on each of you in order as I've seen them. With that, I am just really excited to welcome you to the 43rd session of the UNSY Guest SME Speaker Series. This is the first of 3 for this term. I'm Dr. Brent Terwilliger, the Program Coordinator for the Master of Science in Uncrewed and Autonomous Systems degree here at Embry-Riddle Aeronautical University worldwide. Tonight, we're joined by our guest subject matter expert, Hunter Brown. Mr. Brown is a solutions architect at VideoRay. Sorry, somebody's make sure you're on mute, please, folks. All right, I got to go through manually. All right, here we are. Let's start that over again. Mr. Brown is a solutions architect at VideoRay. He focuses on identifying industry trends and gaps that are driving innovative efforts to meet customer needs and advance the state of undersea technology. The majority of his projects, they focus on new technology integration and application for unique mission sets. Previously, he served as a chief scientist with MITRE, a senior principal, corporate technology strategist with L3 Harris, and an autonomous systems laboratory manager at the University of Delaware. These roles, they led Hunter to work sites around the world in locations like Palau, Fiji, Papua New Guinea, the Solomon Islands, Scotland, Italy, and Australia for government, academic, and commercial projects that spanned a range of maritime systems from tactical buoys to USVs and UUVs and maritime aviation. He's published over 30 articles across academic journals, conferences, and industry periodicals. Occasionally, he enjoys flying small planes, scuba diving, tinkering with and driving classic cars, home robotic projects like app-based automated plant tender, and music, including the banjo and the guitar. With that, let's give a warm welcome to Hunter. I'm excited to explore this field together over the course of our discussion.
Excellent. Thank you so much, and really appreciate the opportunity to chat with you and your students. What a fantastic opportunity. Looks like a really great group from some of the description you were giving, so I'm really looking forward to the discussion. In fact, I may accelerate the talk a little bit just to get to that discussion first. It sounds like we've got a lot of different backgrounds and a lot of different experience, and I love learning, so I'm really looking forward to learning a lot from you all as well. Again, thank you very much, and let's jump right in. It sounds like maritime might not quite be the usual application and specialist you're talking in domain you're looking at. So I'm really excited to get to share that a little bit with you and talk about what VideoRay does and a little bit about the industry in general. So VideoRay itself was a small company, started about 25 years ago out of Pottstown, Pennsylvania, believe it or not, a fairly landlocked area about an hour east-northeast of Philadelphia. During that time, they've grown tremendously. It started off with just a handful of folks and now is over 130 employees. And if anyone's been watching the news or done a little homework on VideoRay, you'd know we've just been acquired by a company called Blue Halo, which does a lot of aviation-related work, counter UAS, space engineering services, and RF communications type services. So we're really excited about that. And then you may have also read that 48 Hours, they were acquired by another aviation company called AeroVironment, who builds Switchblades and Blackwings UAS systems and does a lot of work for our military. So about 2/3 of our sales are into the United States military and foreign militaries, and then about 1/3 is commercial. So we do work with oil and gas, we do work with park services, we do work with local sheriff's departments, state police, a lot of Department of Homeland Security groups, and that includes the Coast Guard, it's called CBRN, Chemical, Biological, Radioactive search teams, et cetera. So we really approach and address a lot of different domains and a lot of different mission sets, which is why they came up with that rather colorful title for me as a solutions architect. And many of you may be asking, well, what does that really mean? It means that when customers have a unique or challenging mission that they need to accomplish and that our products don't address right off the shelf, they call me in. And I go sit down with them and pick their brains, ask them lots of questions, try to understand what their true mission is, or at least what they think their true mission is, and try to help them understand how our technologies can be applied to help them get to their goals. It's a really fascinating role. I love it. I love learning so much from the customers and also helping educate the customers. They often don't know specifically what they need. And in fact, they might walk in the door and say, hey, we need a VideoRay Defender system that can go to 100 meters and fly it. We call it flying underwater, swim at this speed. And it turns out, you know what? They don't really need to swim that fast, it turns out. And they'll accomplish their mission, perhaps maybe even a little better. So it's my job to help understand them, what their needs are, and then educate them to what we feel is the best technology solution, and then guide them through that process, through the purchase process, the training process, the maintenance issues. And I'll bring in specialists from the company when I need a little extra help to ensure that our customers get the best treatment and best service that we can provide. So it's really exciting. I've worked for several different undersea companies. And the industry is just moving at such a tremendous pace. It's a really, really exciting time to be involved with this. Technology is moving so fast. Obviously, with the AI, ML insertions everywhere, it seems that's bringing a brand new dimension to our work, our data products, and our mission planning, actually. So it's really exciting to see those advances as well. Okay, here I said I was going to make this quick, but I'm rambling on. Let's go ahead and keep moving through these bullet points so we can get to the real meat of this, the discussion. Our vehicles, we call them man-portable, human-portable, single operator. You see the folks in this photograph here, each one's holding an older Pro 4 model. Those are being phased out as we move more towards our three main products. We have an exceptional reputation across the industry. Folks come to us from all corners of the world asking about our vehicles and how they can use our vehicles to solve their problems, which is a great place to be in the industry. We've sold over 4,000 of these vehicles, again, across the world. So it's really exciting, and 75 countries. So you can imagine we get to go to some fairly exotic locations, or at least the sales guys and the training teams do. Often I'm stuck in the United States, vicariously living through their great photographs and stories that they have. So it's a wonderful industry to get involved in if you like to travel and you like to be near water. So as a diver, I love that aspect. Don't get to dive as much as I'd like, but every now and then I can sneak in a dive day before or after the actual work, which it's hard to call work sometimes because, and don't tell my bosses, but it's a lot of fun. We have tons of different customers ranging from the United States Navy to big Fortune 500 companies and all kinds of mission sets. So it's really a huge range that's exciting and needs a lot of innovation to meet those customer needs. Our systems are uniquely suited for mission critical applications. And what does that mean? It means when missions have to be accomplished, when the customer has to solve their problem, when they absolutely must accomplish their goals, they turn to VideoRay because our systems are designed for those rugged capabilities, for reliability, maintainability. And if you take a gander at the systems engineering list on Wikipedia, you'll see there are about 50 other ilities, they're called, that are thought of and discussed and addressed as we move through the design process, the training processes, the software development. So there's a lot that goes into some fairly small, simple looking devices that you might not notice just a casual first glance. Just a quick overview, we sell across the world. We've sold more than 4,000 systems to over 1,600 customers, over 75 countries. We rely on a number of international dealers and 13 authorized servicing centers, again, spread out throughout the world, so that if you're unable to solve your problem right there immediately in the field, you can get in touch with one of these service centers at a fairly close geographic location, and they can help you out. In some rare instances, yeah, they can't even solve the problem, and the system has to be sent back to headquarters over in Pottstown, Pennsylvania. But that's growing more and more rare. And the reason that's growing more and more rare is that we've designed our systems to be really modular. Often with the government systems, you'll hear the term MOSA, and that stands for Modular Open Systems Approach. And what that translates to in the real life, in the real world, physical world, is that the thrusters we use across our family of systems are the exact same thrusters on each vehicle. So if you purchase one of the smallest vehicles we sell is called an Ally, we recently introduced, the thrusters on the Ally are the same thrusters that are on a Defender. The same thrusters that are on the medium-sized Defender are the same thrusters on the large-sized WRAITH system that we're about to announce publicly. So don't spill the beans there and let anyone know. That modularity means that when something goes wrong in the field, say you ingest some seaweed, you get sand and debris that clogs the thruster, it's very easy to swap out to a different thruster and carry on with your mission. So our customers demand as much uptime as possible, because often operating offshore, they're paying in excess of 5 figures a day just for the support ship. In addition to the large ships, we also are able to deploy our systems from very small boats, inflatables, a wide range of applications again. So we'll get to that in a few more slides. We've got customers at the bottom listed, obviously the United States Navy, the Marine Corps, the Army Corps of Engineers, oil and gas like ExxonMobil and Chevron, and then a number of other foreign navies and also foreign industrial companies. Often it's pipeline surveys, monitoring the inside integrity of pipes, surveying wells and vats in the food processing industry, as well as the sanitation industries. So a tremendously wide range of activities need and use remotely operated vehicles, as we call them. As I mentioned, there are a number of different domains that use them. Everything from defense to aquaculture to scientific research. We sell a number of vehicles every year to universities and colleges, international shipping, salvage, infrastructure, etc. So you can imagine the wide variety of questions we support and respond to over the course of a year, as we get customers from defense who maybe need to be in a closed off room with no windows somewhere to discuss their needs, all the way to universities that want to publish everything out in the open. So it's a really exciting mix of customers and applications. Every experience brings a little something new, which keeps things fresh also. We never get bored, that's for sure. A little bit more about VideoRay, the company. We've got our headquarters in Pottstown, Pennsylvania. We also have offices in San Diego, California, Virginia Beach, Virginia, Tampa, Florida. We've got team members in Texas, Louisiana, and we've actually grown quite a bit since this map. Now we're addressing New England with folks in Rhode Island, Massachusetts, and then we're continuously growing internationally as well. So it's never a dull moment, even at this small company. I mentioned we have several products now. This slide is growing a bit dated now, but our smallest vehicle, Ally, right in the center, you see these are modular exploded views to give you an idea kind of what goes into them. So you can tell the thrusters on the left side of the Ally. Right above that is a compute module and communications module. Then we've got the tubular. I wonder if, are you able to see my pointer? Yes, okay, great. So this cylinder at the bottom is a battery pack. We offer both tethered and later towards the end of this year, untethered options for the vehicles. The tethered options are varied also. So our tethers can be all copper conductors, which carry power, Ethernet, and RS-485 communication protocols. And then we also have a copper tether with a fiber core, so you can get your power, and then all your communications can be affected over that fiber center. And then we have a fiber-only tether. And the differences there are that fiber offers more bandwidth, typically, than what we're able to offer with just our copper conductors, but at the expense of a bit of brittleness. Also, the copper tethers are quite a bit larger in diameter, which means a lot more drag underwater. So we need to use our thrusters a lot more to overcome that drag as we're swimming around. And then the fiber-only tether is our smallest diameter tether and used for long-range deployments. So you can imagine these vehicles swimming out 1 kilometer, 2 kilometers, even up to 4 kilometers. That's a lot of drag on the system just from the various tethers. So more and more of our customers are asking if it's possible to operate without a tether. Hence, we're exploring these untethered options with batteries and autonomy. The Defender on the left side is kind of our workhorse. We sell more of those than any other vehicle. They are tremendously configurable, and I would almost venture to say that more than half of our vehicles that go out the door have some custom configuration to them, just due to the wide variety of applications. So we definitely keep our engineering and integration teams busy there. Again, you can notice you'll see the same components on the Defender that you do on Ally and the Pro 4. The modular camera system here, same camera system across all our products. It's built in-house. We purchased the imaging sensors from the latest and greatest from Sony and others, and then build our cameras around that to affect the greatest optical, electro-optical vision-based data for our customers that we can. We offer lots of different configurations there as well. You can have multiple forward-looking cameras, multiple aft-looking cameras, various types of lenses, various types of windows. So they're, again, tremendously customizable, which drives our support teams nuts. But we truly go the extra mile to address our customers' needs. The device you see just below the camera is a third-party manufactured forward-looking sonar. And what that does is, if you've been swimming in a port or a harbor or a muddy river, sometimes you can't see very far. So what do? We've still got to accomplish jobs. We still need to help the customers solve their problems and affect their missions. So we turn to acoustics undersea. And this forward-looking sonar can see out several hundred meters, believe it or not, and it generates an acoustic image of the seafloor and the surrounding areas. So again, that's a device built by Blueprint Subsea over in the UK. And then we've got a number of navigation options as well, from inertial navigation systems called INSs to AHARS systems that are probably very familiar to you all on board the small UAS systems. And then at the end, an INS paired with another device called a DVL, a Doppler Velocity Log, really gives us the best navigation solution we have. Unfortunately, those high precision INS navigation solutions often tend to be very expensive. And expensive, that's a great question. Thanks for asking. Ally in the middle starts at about $30,000 to $50,000 US. So it's not quite your hobby level entry. Hey, I've got a pool and need a cleaning device. Maybe I'll buy an Ally. From there, we move up to the Defender, which starts at about 150K. And then you can add on all the bells and whistles to move it up 300K, 400K. About 250,000 will get you a very nicely equipped VideoRay Defender, though, with lots of bells and whistles, side scan sonar, forward-looking sonar, cameras, etc. Again, I mentioned we're phasing out the Pro 4 system. We're about to introduce a larger vehicle called WRAITH that we're very excited about, so watch this space. It can actually host an Ally in a centrally located payload space. So you can imagine swimming a WRAITH out of a host platform, deploying an Ally, and then in certain applications, maybe the Ally doesn't come back. So you retrieve the WRAITH system, reload it with another Ally, and send it back out on the mission. So we're real excited about that. pardon the pun there for the tether joke about real. And then please, again, watch the space for that information coming out soon. At the bottom of the screen, you see our various operator console systems, control consoles. On the left side is our largest. It includes a full computer, Linux-based Ubuntu, and then the handheld joystick. In the center, you see our splash-proof, waterproof tablet. And on the right is another operator OCC, we call them. It's a slightly smaller option with a smaller screen to affect the same. The software is the same across all the vehicles. The vehicle dynamics are tuned a little differently, that profile based on which vehicle is specifically operating, but all the control systems are the same, the inputs are the same, and it makes it really user-friendly because if they learn one system, they don't have to learn a new control system for each vehicle. So that interoperability is key as we move forward through our family of systems. Real quick, would you prefer for me to pause to offer folks a chance to ask questions now, or would we prefer that to be at the end?
At the end.
Roger that. Okay, so I've talked a lot about modular missions. We call it mission specialist in the company, but that modular ability to move components across all our vehicle lines. Over on the left, we've got some great pictures showing the modular manipulator sets we have that are articulated arms. It looks pretty beefy, but believe it or not, the actual arm mechanics are fairly small. What you're seeing there is actually syntactic foam. So it's flotation to offset the weight of the mechanical arms. One interesting thing about the vehicles that you might not think about right off the bat is that as the arms are extended, the center of balance changes on the vehicle. So you can imagine that the pose the vehicle assumes as the arms are moving through their motion changes. So that's a really interesting dynamics problem, because if you reach out and try to pick up something heavy, the aft end of your vehicle will float and the front end of your vehicle will sink. So how do we then maneuver the vehicle in that strange orientation? So we've had to build a unique 6 degree of freedom controller so that the vehicle can fly in these unusual attitudes when it's manipulating objects or lifting, pulling various objects. At the bottom, you see we operate in all kinds of conditions, from icy conditions at the poles to very hot places in the Middle East. Often we're asked the question, what's the temperature range your vehicles can survive and be operational? And we like to say, as long as the water is liquid, we can operate in the water. But then customers often don't think about perhaps they're going to set up their system on a hot deck exposed to the sun in the Middle East and then sail for hours and hours to get to a site. So we also have to think about how hot the internal systems will be cooking on the deck of a boat, how hot the batteries will get when it's set in a standby mode, just sitting on a deck. And then the same thing for cold. So in cold locations, they'll often be sitting directly on the ice or again, on a very cold deck before it goes in the water. And you better believe that in that bottom left picture, the temperature there is much colder than the water below the air. So we have to think about these things when we're designing the vehicles. How long will a vehicle be exposed to those various hot and cold conditions before it even gets to the water? Some of our sensors, like side scan sonars, also don't like to be operated in the air. Right now, we're using third-party suppliers like EdgeTech, Marine Sonics, and various other acoustic providers, vendors to provide us those equipments. Some are fine operating in air for minutes. Some automatically enter a standby mode for hours, et cetera. So those are all concerns. And how do we train and educate the customers to be sure that those systems are operated in the environment that they're intended? Moving along, the Ally has a number of different flotation options, depending on what your mission is. On the left, you see the rounded float, a nice streamlined system, great for pipeline inspections. It's very smooth, not many appendages, not a lot of drag, not a lot to get caught on things. On the right, is a more expeditionary type unit. It's got 2 battery systems underneath, but due to the weight of the batteries, we must counteract that with increased flotation on the top. The flotation we used is called syntactic foam, probably not well known in the aviation industry. It's essentially a closed cell foam that's injected with glass microspheres. And those glass microspheres don't get crushed the deeper you go. Whereas if you have another foam, say styrofoam, which is an open cell foam, those air pockets tend to crush. And if you've ever seen those deep alvin, for example, from Woods Hole, diving down, sometimes they'll take a styrofoam cup, and when it comes back up, it's about 1 inch tall. So it's really exciting to see those demonstrations and a fun souvenir from the dives. Haha, I'm giving away the secrets here. So this is WRAITH. This is our newest vehicle. We expect it, we're a little late, it looks like, but we expect it this year pretty soon. We've built a prototype, it's operational, it's running. We're putting lots of hours in testing. We want to make sure that it's as bulletproof as possible before we actually hand it over to the customers. This vehicle has 10 thrusters. 4 are situated in the aft. We've also added our 6 degree of freedom software on it so that it can fly in any attitude. The front end of the vehicle rotates, so you can point or aim your sensors towards your target of interest. You can imagine swimming along looking forward is great, but what if you're interested in something on the seabed? So you can rotate that entire center section to point directly down or to point up as well. An application where you point it up might be performing a ship hull survey. So you're interested in what's the condition of my hull? Is there anything attached to my hull that shouldn't be attached to my hull? Or inspect for any mechanical damage if there's been a collision. So this is going to usher in a number of new opportunities for both VideoRay and our customers. We're very excited about this. As I mentioned before, WRAITH can host an ally and be used for a number of different applications. We're going to skip ahead. So as I mentioned before, about 2/3 of our sales are government, Navy addressed. And we recently won what's called a program of record, the Maritime Expeditionary Standoff Response Contract, about $90 million to perform mine countermeasures activities and neutralization activities. What does that mean? So in lots of places around the world, they have a problem with derelict mining from previous conflict. And they have to have a way to neutralize those mines, to open shipping lanes and provide safe passage for both commercial and recreational vehicles, in addition to the Navy vessels. So after identifying the location of these mines, they need to go remediate them, either recover them and make them safe or neutralize them in place. And so the VideoRay ROVs, Undersea systems, are the vehicle of choice for a number of different navies. And we offer lots of different options on how to accomplish those feats, such as grabbing on with a gripper at the end of a manipulator for recovery. We offer cutting tools so that the mooring lines and tethers can be cut. And then we offer neutralization packages that use kinetics to actually essentially work as a can opener. So they use kinetics to peel open the mine, let it flood, neutralize it, and sink. At the same time, they don't cause the mine, we call it going high order, they don't cause the mine itself to set off and give away a position. So lots of options there. We're real excited to support those demining activities around the world. The MESR program is a family of systems. So we're constantly upgrading the vehicles with new software, new mechanical capabilities, new depth capabilities, and we're passing those on to our customers around the world. So we're very excited, both within the United States Navy and other government and commercial and academic customers around the world. So again, very excited about this. And there's an interesting point you see about midway down. It says unmanned systems with Navy production contracts are rare. The reason for that, there are actually many reasons for that, but the primary reasons for that is that uncrewed systems are complicated. A lot of folks don't understand them. And the early marketing and messaging within the naval command structures was not well done. So there was a lot of confusion in the ranks a lot of confusion in Congress about how to actually acquire the systems, maintain the systems, field the systems, and update and upgrade the systems. So that is being overcome slowly across the industry. And we have a lot of precedents we can point to with the aviation industry and look at the success stories there to translate into maritime. Unfortunately, maritime tends to add a 0 or 2 or 3 zeros to our similar friends above the sea surface projects. So it's a little more challenging sometimes to get in with new customers than perhaps some of the smaller UAS systems. We've got a number of Navy programs outside of the MESR program. We've got the low observable, no collateral damage with ONR. It's called Nicely. We've got a number of projects with the United Kingdom, also Australia. I'm here at Sierra Space Convention this week in Washington, D.C. at the National Harbor, talking with the navies from Chile, from Japan, from Canada, from Lithuania. So really, it's truly a global market these days, and we've got to be prepared with products, training, and partners who are in place to help not only technologically but culturally as well integrate these products into their teams. So we're real excited about this. Looking ahead, we've got a number of opportunities to enhance our technologies. We've got obviously the special purpose vehicles. Generally, those tend to go into the Navy. I'm not going to talk too much about that. Folks are always interested in launch and recovery systems and tether management systems. If you've ever tried deploying a lift bag undersea when you're diving and you let a little slack get into that line, it immediately becomes a rat's nest and entangled with itself and is a real hassle. Sometimes you have to cut it loose and use a backup. And other times you just sit there and work through the tangles. It takes a long time and it's really annoying and can be jeopardizing of the missions. So it's critical to manage that tension in the tether throughout the mission as well. You see novel flyout and deployment solutions with a number of different host platforms, everything from subsea vehicles like submarines to very large surface vessels as well. And they all have their challenges. So surface vessels, for example, a number of our operators use small boats. So they go out, they don't have a lot of room on the deck. In fact, there may not really be much of a deck to speak of. And so they've got limited space. They may have a limited number of crew that can manage the systems. And then getting the vehicle in and out of the water might be a little bit of a challenge due to the riding moments there of the boat and the vessel. And then large vessels, on the other hand, might have freeboard. That's the distance between the sea surface and the gun on top of the edge of the railing, for example, on the ship, could be up to 20 feet. So how do they lower that vehicle over the side down that 20 feet and then get it into the water appropriately and then conduct their missions? So lots of different options we're exploring there, always looking for new solutions and new suppliers and vendors that can partner with VideoRay to help us accelerate that path to market for these solutions. Obviously, as a bullet point 3 says, we're always looking to expand those partnerships. That's not only on the mechanical side, that's also on the software side as well. As we've learned, watching Microsoft and IBM and a number of other groups, OpenAI, software is really easy to scale. I can copy and paste and sell 1,000 copies with much less effort than I can 1,000 physical systems. So we are exploring new ways to get autonomy and other software packages out to the market, to our customers, and to our friends as we continue development efforts there. So lots of opportunity there in different ways, different pathways, different business models to getting those software packages out and upgrading them and integrating new functionality and features to the packages. And finally, we're not standing still on the virtual reality and augmented reality front either. We've had an internal group called VideoRay Labs. It's now being moved into a more innovation-focused team across Blue Halo and AeroVironment. And that team really focuses on three-dimensional visualization, 3D mapping, 3D reconstruction, acoustics for generating those same spaces, teleoperation, and then providing that three-dimensional awareness where previously operators had to rely on single cameras to affect their missions. And in fact, when I was young, I took a tour of a company called Remotech that built tracked land vehicles and was asked to go pick up a grenade using a manipulator arm. And they only had one camera, and it was quite frustrating, actually, the times I missed grabbing the grenade because you just don't get the depth perception. So we're looking into adding multiple cameras and providing novel visualization tools to give our operators that three-dimensional perspective. I'm just going to skip through a couple things. So this is, again, special manipulation. On the right, you see we've got two arms, articulated arms, and we're recovering a box there. It's conveniently got some nice handles to grab onto. So that was very nice of whoever and considerate of whoever left that box for recovery. On the left side, you see we're attaching a carabiner with a line to another handle. Perhaps that's to mark the location. Perhaps it's to attach an acoustic beacon that can just ping away for later relocalization. Or perhaps it's connected to a buoy that will float up to the surface and mark that location. So lots of different options. Those black foam members you see on top of that left vehicle, that's additional foam based on the arms, the mechanical arms. We offer all kinds of specialized tooling. I'm not going to go into this too much, but what you see here is mine neutralization tooling. Often third parties develop that and then work with us to tightly integrate that into the Defender system. Again, more specialized tooling. You can build custom sleds, skids, and integrate your own sensors. You can integrate a number of various off-the-shelf commercially available sensors. We speak RS-485, like I mentioned, and Ethernet all throughout the vehicle. And then we can certainly affect custom communication schemes if you're interested in that. Here are some data products over on the right-hand side. So these are three-dimensional products that offer various accuracies and precisions. So on the top, you see a pipeline survey. In true acoustic fashion, you'll see some dark areas behind the pipeline. And the reason for that is it's called acoustic shadowing. So just as if you turned off the lights in your room and picked up a flashlight and shone the flashlight around the room, it would cast various shadows. And this makes it very difficult for automated target recognition systems. The reason is that if you imagine a cylinder, if you shine a flashlight from one end of that cylinder, it would cast a circular shadow. Now, if you move the flashlight to the midpoint of the cylinder and shine it, it looks like a rectangle. So with your acoustic image, you really don't have a good idea unless you fly the vehicle around the object and minimize those acoustic shadows and get a really nice picture of what you're looking at. On the bottom, you see a shipwreck. And you can see it in relief view. Again, that's a three-dimensional data product, most likely created with what's called an interferometric bathymetric system or bathymetry system. It sends out a number of acoustic pulses based on the time it takes for those signals to move from the transmitter and out to the object, reflect off the object, and return to the receiver. We can actually build very precise models of the seafloor and the pelagic spaces if there's something in that mid-water column that we're interested in seeing. Here are a couple other data products that are available. This is a forward-looking sonar. We generated some 3D maps. It's really cool. You see some color highlighting, and the objects really stand out from the seafloor. So it makes the real-time operation by human operators much easier than if it was traditional optical based or previously side scan sonar based. Where are we working on innovation? It's not just one place, as you see, it's across the board. Camera technology is improving all the time. We want the latest and greatest on our vehicles, and customers demand it. We've got new vehicles coming out through the pipeline, smaller, larger, special form factors. You name it, we're thinking about it. And if we're not thinking about it, we'd love to hear your ideas as well about where we can go from here. The human machine interface and the control systems is a tremendous opportunity, an area for innovation. I mentioned before the virtual reality headsets, augmented reality headsets. They're great when you're sitting in your living room, looking around and playing a game. I must admit, I love being on the water, but as I'm getting older, I'm finding I'm growing more and more prone to motion sickness. And my daughter has a roller coaster game she loves playing in virtual reality. I found I can no longer play that game. Same thing happens at sea. You can imagine an operator sitting in a chair in a deck that's rolling and pitching and heaving. Then they're donning a virtual reality headset and then experiencing totally different motions visually as the vehicle at depth is being acted upon by currents. So it's a challenging problem that we hope some innovative person, perhaps one of you, will come up with a great solution. And I hope you do. And come knock on our door. Please send me an email and let's chat. 3D mapping, folks want high resolution. They want to understand what's going on in and around the vehicles, that situational awareness. Coupled control and manipulation. What that means is, how do we use those arms to perform work while also driving the vehicle? We talked a little earlier about the buoyancy problems. The center, it's called meta-center, where the center of buoyancy and center of gravity diverge, then the vehicle takes on unusual attitudes. The same thing with our software. We've got all kinds of cloud work going on. How do we move large data sets to the cloud? How do we operate on them? How do we get customers the data products they're looking for faster? Special tools. Hull cleaning, you can imagine that's a hull cleaning brush. It's got bristles for mechanical scrubbing action, and they can also pump high pressure water through as well to pressure wash the hulls. Fine motor manipulation, so all kinds of different end effectors on the arms, cutters, scoops, grabbers, kinetic devices, and other kinds of things are very much of interest to our customers. As we move forward, increasing our autonomy, mission planning is more and more exciting to us. So instead of a manual operation by an operator for the entire mission, we're now able to pre-plan a mission using geographic waypoints, just like your small UAS and larger UAS, put the vehicle in the water and push go. Obviously, a lot more concern about recovering the vehicle during those types of missions and tracking the vehicle during those types of missions. Unfortunately, undersea, we don't have the luxury of RF communications, radio communications, because radio just does not propagate underwater. It's attenuated very quickly, and I'm talking inches, not feet. So how do we get around that? We use acoustic modems. Unfortunately, unlike our surface and aviation and space RF modems, these acoustic modems are very slow. And when I say slow, I'm talking, we're essentially tweeting 120 characters to the vehicle and back. So our messages have to be very concise, and really the critical information needs to be sent. We're not streaming live video acoustically. We're not sending sonar data. We're not sending gigabytes. We're not even sending megabytes of data. It's literally on the order of bytes and low kilobytes right now. Unfortunately, we're at the mercy of the speed of sound. So speed of sound underwater is roughly 1,500 meters a second. So if you want to talk to something that's 1,500 meters away, there's already a physical 1 second delay built in just from the physics. So no matter how great your acoustic modem is, it's going to take 1 second for that frontmost acoustic pressure wave to propagate from your transmitter to the receiver 1,500 meters away. There are some innovative products coming out on the market right now, which we're really excited to partner with groups like OceanCom that are exploring essentially beam steering solutions for acoustics, which align the transmitter and the receiver through that electric beam steering of the transducers. So they have a really tight boundary and can affect some higher bandwidth throughput on those acoustic links. Excuse me. So very excited, lots of innovation going on there, lots of opportunity. The same thing in the mixed reality as we've discussed, and simulation and training. More and more folks are interested and eager in using our virtual reality training tools. because they can send that to as many operators as they want, who can all go through the training at the luxury of their own, where they are, the location around the world, and they don't necessarily need access to the physical hardware. So it's a fairly low cost training situation and opportunity for these companies to effect wide-scale training at a fraction of the cost of providing vehicles for every operator to go through that physical hands-on training. We found it also increases the ability of the operators the first time they're presented with the actual hardware. If they've gone through the simulation training, then we find that they're much faster at accomplishing the physical tasks than if they're just introduced to the vehicles the first time and asked to accomplish those tasks. So lots of opportunities there as well. And finally, again, launch and recovery systems. This is huge. Everyone's doing this right now, looking at these problems. And the first to come up with really good solutions is going to do very well in the markets. Launch and recovery systems are affected from large surface vessels, crewed surface vessels, uncrewed surface vessels, subsea vehicles, platforms. So you can imagine oil and gas platforms. They like to go out and inspect their hardware on a daily and weekly basis, so they can dock the systems, dock the vehicles, and then send them out automatically for those repetitive missions to perform change detection. And believe it or not, the same thing from aircraft. Specifically, there are a number of helicopter platforms that are interested in deploying ROVs. They can quickly get on site, drop the ROV down a line using a descender so that it doesn't just crash into the sea. And then the ROV conducts its mission and then is recovered back into the aircraft. On the other hand, for fixed wing aircraft, we're also exploring deployment methods. Often that's with parachutes or other drag mechanisms that can ease the entry between the air-sea space, air-sea interface there. Again, so that the vehicles don't just hit the water and explode into pieces. As you can imagine, those types of deployments are reliant on long-range communications, RF based at the surface. So how do we get around that? Well, we think start putting on that innovation hat. You could have you could use buoys, so gateway buoys that have RF modems on the top and acoustic modems undersea. You could trail a buoy with an RF modem at the sea surface. So lots of different options, and certainly looking for new options and new innovation there all the time. VideoRay Labs. Speaking of innovation, as I mentioned before, VideoRay Labs is really focused on what's next, what's coming in the next year, 2 years. I'd like to say 5 years, but everything's going to be so different in 5 years that nothing we plan for now will be the same then. So VideoRay Labs is highly focused on vision products right now. So enhancing that spatial awareness, that situational awareness, what's going on in front of the vehicle, what's going on to the sides, what's going on behind the vehicle that might impact my mission, is a huge bed of kelp drifting into my op area, and it's going to foul all my thrusters. I need to make a change now if that's the case, and I need to be aware of that. How do we present that environment to our operators? Previously, it's a first-person view from the camera. What if instead we can provide them a third-person view showing a model of their vehicle in a 3D reconstructed environment that's the real world that they're operating in? A lot of our customers are really excited about that capability, and it's coming faster than we're expecting. So a lot of new technology is being thrust into the undersea domain all the time. This is a boring slide. Let's move on. We're also working with other platforms, some rather large subsea platforms. We're working on mixed reality. So we have a project right now with the Office of Naval Research on multimodal input to control heterogeneous assets. Those are big fancy words to essentially mean sometimes operators want to speak their commands into a headset, and the vehicles then respond to that, those words. Spoken words. Sometimes they aren't in a position where they can verbalize words and they want to use hand signals. So they can effectively use sign language, and cameras in the headsets pick up those signs and then translate them into messages for the vehicles. Sometimes they want to push buttons. Sometimes they want to actually grab a controller and steer a vehicle around. This also offers those operators the ability to control multiple vehicles across domains. So at the same time, they might be issuing high-level commands to a UAS, for example, to orbit an approaching cruise ship and image the deck and get a good idea of what's going on above water with this ship. And then at the same time, they might issue commands to an undersea vehicle to orbit subsurface and inspect the hull. Is there anything attached to that hull that shouldn't be there? Is there anything attached to that hull that could cause damage to the ship or the port or harbor or dock that it's headed for? So this system will allow the operators to effect all of those different types of commands, and at the same time translating the operator's intent to the specific proprietary message formats and protocols needed for the end asset. You can imagine an undersea vehicle, for example, needs an acoustic modem to talk with, whereas a UAS can use an RF modem. So our system, it's called Mismatch, connects the operator using a common vocabulary to all of these different endpoint robotic systems. So it makes it really easy, compact, and the operator doesn't need to carry 10,000 different communication systems and control systems and learn and be trained on all those systems. They only need one. So we're real excited about that and where it's headed in the future. Here's just a sampling of images with some different configurations, lots of different configurations, lots of different technologies, always exploring, always looking at what else can we do as VideoRay to help our customers achieve their goals? And that's really a trending theme across all the different teams within VideoRay. Is what can we do better? What can we make easier on our customers? Is it putting arrows that point to different things on the system so it's easier to assemble? Is it in software? Is it making a button a little bit bigger so that if you're on that pitching, rolling, heaving deck, it's easier to press that button? Is it audio alarms and bells to alert operators of specific conditions on the boat? Personally, when I'm up and when I was first starting out and going through my flight training, I realized that when I was task loaded, I turned off my ears. I did not listen to what my flight instructor was telling me. I did not listen to audio alarms. I was totally visually focused on the dashboard. What are my gauges telling me? And it took me a while to get over that. But I realized also after going through a number of different virtual reality trainings, our users do the same thing. We spent a lot of effort building some very cool simulation products with audible alarms and voiceovers for different sections. And after taking off the headset, we asked the customers, hey, what do you think of that instruction or that alarm? And they've literally come back and said, what alarm, what instruction? We didn't hear anything. So that's been a really interesting lesson we've learned in ergonomics. How do we help our customers learn as fast as possible and become as proficient as possible without extra information and undue complications and distractions. Here's another example of mixed reality. So instead of providing a headset that you look all around, we can create virtual monitors, and these virtual monitors can be very large. Often much larger than even movie theater screens virtually as presented to the eye. So lots of folks are interested in that. We've got some projects with Oceaneering, another large subsea company who does commercial and government work as well, to help them with their work class ROVs, which are much larger. And when I say much larger, you can imagine a large SUV that's about the same size as those work class vehicles. So they have lots of cameras, sometimes 10 or 15, potentially 20 different cameras monitoring various aspects of those ROVs. So we've helped them provide those real-time video feeds in virtual environments like what you see in this image. They give operators one area to look at and they can see all the screens instead of having to physically turn their necks and look around a control center, a big control van, if you will, with lots of physical monitors. So lots of space saving, and it also presents the information in a more understandable and faster presentation mode. Here's another quick slide on our mismatch project. We show A single operator can use headsets or tablets or cell phones to connect through DDS, which is a data distribution service middleware layer that's growing more and more common across robotic platforms to a number of different endpoints. Sometimes that's an undersea vehicle, like one of our Defenders. Another time, it might be a DJI Phantom, or it might be a Skydio vehicle. So lots of different opportunities there in the translation, converting that common vocabulary, those common messages, like hover. That means something slightly different to an aerial vehicle than it does to an undersea vehicle. Undersea, we've got to worry about, is our tether going to be tangled? Do we have a tether? Are we going to find ourselves in a current, perhaps, as we're orbiting? And in the undersea space, going to the surface means rising for recovery. And obviously in aviation, we want to come back down to the ground to recover our vehicles in a safe manner. So lots to think about. We're trying to make our systems as open as possible and flexible as possible, because inevitably, when we lock down a configuration, inevitably the very next customer will say, well, that's great, but can you? And so we go back to the drawing board then and adapt our systems, and it's great. Last slide, we're certainly not missing out on the AI. It's a tremendous opportunity, and we're applying it across the company. One of the really exciting areas is mission planning. So how can we use artificial intelligence to scrape bathymetric maps, current weather information, to pre-plan our missions in a really intelligent way very quickly, whereas a human operator might take days or hours to come up with a similar plan. Similarly, we're also using AI to scour our manuals, user manuals, so that in the field, instead of having to flip through a manual to find a section on how to accomplish a certain task, you can either verbally ask, hey, hey Siri, essentially, how do I do this? And the AI systems will have that knowledge and awareness of our manuals and can respond intelligently. We certainly have lots of testing to go, and as we're all learning now, these AI systems or large language models are prone to hallucinations, and that's unacceptable. Some of our customers have very specific missions, and if they need information, that information has to be 100% correct. Similarly, I imagine in the aviation world, for manned crewed aircraft and passenger aircraft, similar situation. We're not in a place yet where we can rely on these AI systems to guarantee passenger safety. So we've got some work across the industries there, but again, it's approaching faster and faster with every day. Really excited about where it's headed. Lots of opportunities. We're just not quite there yet, but we will get there. Whew. All right. I think we've covered most of the deck. Now we're to the exciting part, and I can learn from you. Thank you so much for your patience. This has been a real privilege to be able to present this material to you, and looking forward to the discussion.
This was amazing and in-depth information, so I appreciate that, Hunter. And just to kind of reiterate something you had just touched on with AI and machine learning, the discussion actually came up today about how it's not there yet. And in a safety critical environment within aviation, we absolutely cannot rely on it without verification and validation. Even in small UAS operations, we're not at a point where that reliability has been proven to a sufficient level, that we can start to consider routine incorporation. I want to touch on just a couple high-level questions I have before I kick it over to the students. I am positive they're going to have some detailed questions regarding the tech. So I'm going to keep mine. I'll ask one tech question, and then I'm going to ask you just kind of high-level your perspective on the field.
Absolutely.
So one area I have some experience in is in M&S, modeling and simulation. And I saw you showcased the modularity and high configurability of your systems, while also touching on the importance of M&S to your customers. Are you working on any digital twinning or digital dynamics models that can help customers to understand both the capabilities as well as those trade-offs that are inherent to the system when they want to hang different components off. Is this going to result in that imbalance? Is this going to require some of those unique, end effector motions that we know are, very difficult to plan those out. And then, is that going to affect the 6 DOF, 6 degrees of freedom control set that you mentioned? And just for students' awareness, 6 degrees of freedom is it's vector movement and it's rotation about X, Y, and Z. Right hand rule is the easiest way to think about it, but pitch, roll, yaw, surge, heave, sway. So
Hey,
that's
very
the
good. Excellent.
that's the easiest way to kind of cover that. But yeah, over to you.
Yes, absolutely. We're thinking about this. And, I've had to learn a hard lesson in the business world over decades, unfortunately. When I was younger, I loved building cool widgets. I love build the latest tech. I would jump in and build a project, and I thought it was so cool. And then it turns out, yeah, the next guy didn't think it was that cool. The next customer wasn't interested in it, and I had just wasted all that time and energy and focus, and no one was buying it. So what I learned, and I'm still learning this, is that even when we know that there are really cool applications and things we can build and devote attention and effort to, our customers may not be thinking that same way. And again, unfortunately, we all need to eat. So we've got to continue selling things that customers want to buy. We have not to date have a lot of interest in detailed M&S products. That's not to say that there isn't interest, there is, but often customers are not willing to invest big dollars to generate those M&S simulations, often that it takes. We've also found that with the M&S tools, it's critical to understand what they are trying to gain from the modeling and simulation, because we could go spend millions of dollars modeling every motion of kelp and sand, a grain of sand undersea, and rock and rust and current and weather. And it turns out maybe they just needed an inverse kinematic model for their gripper so that they could see an object and be able to plan their motions to get to that object. So it's really critical to understand what the customers are interested in, what problem they're trying to solve, and then what's their budget and appetite for research and development costs.
Excellent. So now switching gears a little bit, I'd like to pick your brain. You've worked across multiple mission sets and platforms. What current capability gap in the technology in underwater uncrewed systems do you think deserves the most attention right now? Where should we be focusing?
Oh boy, that's a loaded question, because there's not just one. There are two primary for me: power technology and communications. Power technology right now is a huge gap, and across the industry. We need higher power densities, energy densities in our batteries. What does that give us? That gives us more runtime. That gives us more flexibility. That gives us more opportunity to perform new mission sets for the customers. Perhaps we can go tetherless and have more redundancy and failback capability if we've got just a little bit more power. And then on the communication side, we talked about some of the challenges: the speed of sound and water, the inability to truly send real-time video wirelessly through the undersea spaces. If we can increase that throughput, it opens tremendous opportunities for new mission sets and increasing the efficiency of older mission sets as well. So sending large batches of real-time data, large data packages, how do we move that through the water? How do we get that from the undersea up into the RF modems and back to shore so that it can be operated on and make decisions faster? Often, a lot of our mission sets are focused on faster decision making. And so the combination of higher energy densities, better batteries, smaller batteries, safer batteries, and then high bandwidth communications like we have above the sea surface. Those are kind of the killer apps that we'd love to have.
Well, and that's one of those areas that I'd really like to remind the students. We see a lot of cross-platform, cross-domainal potentials. And this is something that if you see the technology developed for one area, it's going to have ripple effects across the industry, across the field. Uh, Battery tech, think of all the places that this could be applied. EV tolls right now in advanced air mobility. If we could get them off APUs, auxiliary power units, we can extend the safety, extend the usability, make that a more financially feasible prospect. Even into UAS and even ground systems. A lot of vehicles are moving electric, EV based for different benefits. If you can have that extended capability, you have longer runtime, you have quieter runtime, you have more power available to the wheels as higher torque levels. So there's a number of benefits. On the comms side, yeah, if you can extend communication through various means too. Maybe we're talking something that could be adapted into spaceborne systems, whether it's what we're looking to accomplish on uh, bodies like Europa that have that subsurface maritime environment, or even just from that remote environment back. We've talked a lot in field, kind of at the moment, bit of pipe dream, but the potential for quantum communication with entanglement. It's all small steps, and in one day if we can get there, it's going to be revolutionary. And this is something I think in UAS we saw uh, mid to early 2000s around the commercial release of lithium battery chemistry. It just changed everything that we're doing. Really, everything we're talking about came out of that capability of now we have this high density, low weight power output that maintained its voltage well through the power curve. So, uh, okay. So one last question for me, and then I'll turn it over. This is more about industry trends. In your current role at VideoRay and now with integration into both Blue Halo and AeroVironment, what new trends or use cases are emerging that you think are going to shape the next generation of UUV or ROV operations?
Yeah, and that's a tough one because we're presented with different missions almost weekly. Customers wanting to do new things. It's a great time to be in the space actually for that reason. Obviously, the autonomy applications are receiving more and more attention as autonomy proves itself and people get more trust in the autonomous systems that they will actually perform their missions and come back to the operator. So that's the autonomy is one. That's it's a really exciting trend that folks are going less to human operators and relying less on the human operators, allowing the human operators to focus on higher level tasks in the mission planning, mission goals, mission trends, instead of the low level, do I need to move a thruster or do I need to turn on and off lights, et cetera. So that's one area that's really exciting. Another trend that we're seeing is that customers are interested in smaller systems. So the conflicts right now we've seen in Ukraine have highlighted the benefits of small UAS systems. Similarly, in the undersea domain, customers are interested in smaller, lighter weight, faster to the field, faster to their targets, faster to the decision making, and faster to gathering information that can support decision making. The swap, size, weight, and power. That's the second. Everyone wants smaller sizes, more capable vehicles, lighter weight, and then more power at the same time, and low cost. Everyone's always trying to negotiate a deal. Don't blame them. Undersea is expensive, but right now the industry is addressing these needs more slowly than we would like. For example, launch and recovery systems, huge right now. Again, if anyone on the line has some ideas, we'd love to talk. The group that solves kind of a universal launch and recovery system is going to win a lot of business and transform the industry.
Yeah. Excellent. Well, with that, I'd like to turn over the opportunity to ask some questions of the students. If you don't mind, just raise your hand and I will try to call on you. Looks like we've got Joe. Joe, do you have comms? Joe Ferretti?
Okay, sorry about that. Okay, I'm good now. I appreciate both your times tonight. So just a quick question, tying into Dr. T's second question. What are some other difficulties for the untethered systems? Like, say we solve the communications and power issues you both spoke of. Are there still other sectors that need to be solved to really, make that a great system, I guess?
Yeah, appreciate the question. Absolutely. So one is the system reliability. It needs to be able to be recovered usually. So that's one. How do I have faith, trust that the vehicle will be able to affect its mission and is smart enough to overcome any challenges it might have between the end of the mission and the recovery portion? And what do I mean by that? Is it smart enough to avoid obstacles, any physical obstacles that are in between where its position is now at the end of the mission and my recovery position? Is it smart enough to avoid entanglement hazards? Is it smart enough to get back to that recovery location at not only the place, but the time I'm expecting it to be there? If we assume no comms in UUVs, the torpedo-shaped type robotics, it's often a pretty scary situation when your $1 million vehicle is running fully autonomously. You don't have communications, and you don't know if it's going to be at the recovery spot today, tomorrow, or never potentially. So that communication really is about the trust factor. Is it on mission? Is it performing as expected? And can we get it back? Another aspect of that is sometimes operators don't want the vehicle back. And if it's fully autonomous, maybe I need to ensure that if it can't complete the mission and come back, that it physically destroys itself or scuttles itself. And then what level is acceptable risk for that particular operator? So lots of challenges there. It's really exciting discussion. I'd love to talk to you more about that offline sometime.
Thank you. I appreciate it.
Excellent. Jacob?
Hi, Dr. T. Thanks for joining us, Hunter. So before I had a question, I found it interesting that in Ukraine with electronic warfare, I saw recently they're testing fiber optic cables up to 20 kilometers long. So yeah, it's becoming an underwater problem and a above water problem to get communications through. But my question was actually, have there been any unexpected use cases that customers have found for your products that surprised you?
Yes,
The
actually.
mind clearing is probably not one you thought of, but yeah, anything like that?
Yeah, and I'm actually going to point back to my UUV days with the torpedo-shaped vehicles. Most of those vehicles are used for search and survey, mapping type activities, mapping chemical plumes or spills, or geographic mapping, bathymetric mapping. And then NASA came and knocked on our door and said, this is great. We want to do mapping. We want to do all the things that you do here. We want to do it on Europa. Excuse me? So obviously, the various moons out in space are quite a bit different from our terrestrial and aquatic regions here. They're different temperatures, they're different chemicals, they're different pressures. So things that might be just fine corrosion-wise in our oceans here on Earth, the chemicals that are liquid bodies on celestial bodies might accelerate the corrosion times in an unacceptable rate. So it might be that the hulls fail at a much faster rate in those extraterrestrial bodies of liquids than they do here on Earth. So that one was really excited and threw us a curveball. We all got real smart on several different moons. Where previously we just literally that was out of this world for us. So that was an exciting one.
That's great. Thank you.
We have a question over in the text chat from IO. What major challenges do you face from regulatory bodies?
I know regulation in the aviation world is immense, and we like to say that Undersea is the Wild West. There is very little regulation. What regulation exists is often related to fisheries and exclusive economic zones, the EEZs that surround each nation. But beyond physical space occupancy during certain times, there is almost no regulation. Any depth, any speed, have at it. That presents several challenges that you might not expect. So any depth, any speed means that you're responsible for collision avoidance. Anybody could be zipping through your water space at any time, any direction, any speed. There are no airways. There are no seaways undersea right now that are defined. As Dr. T, if you will, as he put it, the ocean is a big place. The airspace is also a big place, but there are quite a few less vehicles moving around subsea than there are above the water surface. So right now, it's more or less on you to define and conduct safe operations. I imagine the regulatory bodies will take a much closer look as the number of vehicles increase in the near future throughout the world.
Excellent. We have some more questions showing up over in the chat. Adam
Excellent.
asks, with a worldwide customer base and working in such an innovative space, have you faced challenges from export controls like Export Administration Regulations, or EAR, or International Traffic and Arms Regulations, that'd be ITAR?
Excellent, good question. For the most part, our systems are commercial, EAR 99 regulated, so they're more or less sold as commercial goods. And right now, our biggest challenge is our current administration and the tariffs they're imposing throughout the world. So we're watching that on a daily basis, trying to figure out how we can support our customers. A big challenge is the perception of sourcing products from the United States has changed recently. So we're working through our international dealers to try to overcome those and find creative ways to minimize the cost burden on our customers. We don't have too much ITAR. We obviously have some. Predominantly, ITAR items are not sold internationally. Just the folks aren't asking for it right now, and it's not easy to get around a lot of that. We do have partnerships, and through foreign military sales opportunities, we work closely with our government, and we can get around that and ensure that our partner nations can get the gear and kit that they need to accomplish their missions. So yeah, always looking at it. I'm not a lawyer. Thankfully, we've got really smart people that can solve those problems, and I can stay focused on the technology.
We have a question from Tony. How do you deal with the time delay present in acoustic communication in the water when you work in conjunction with a UAS?
Yeah, right now, tethers give you real-time comms. So if you can put up with trailing a tether, that's how you do it. Otherwise, it's just like NASA. We've got to really be careful about our communication rates and when we expect to hear communications back and forth. Another way is those gateway buoys. So potentially you could trail a tether just up to a buoy and not your operations control center. And that buoy could have real-time comms to the vehicle through the tether, and then RF comms at the surface. Otherwise, we're unfortunately at the mercy of physics.
Excellent. Looks like Christine has a question.
Yeah, so I have a question on customer relations. I come from a aircraft maintenance background. So my question is, like, recently up at Maxwell, we went from getting, we had C-130s, and then Boeing delivered us our new MH-139s. And so when you guys deliver a customer one of your vehicles, do you provide like TOs for maintenance on those vehicles or instructions on that? Or do you maintain the contract for maintenance on them? And then when something happens, they have to call you and ask the question of like, hey, can someone come out and fix this? Or is it a training, like you said that you come and train them, but is it training just on the use of the vehicle, or is it all the components of the vehicle?
Right. So we offer a number of different support packages. Some folks just say, hey, look, train us on the basic operation of the vehicle. We can take it from there. Great. Those customers, about half of them actually accomplished their goal, and about half of them are calling a few weeks later saying, well, how do we do this? Can we talk about some extra training? So we offer several different training courses. One is an operator training course. One is a field maintenance training course. And then we offer some higher level training courses back to the depot level maintenance training program. So we don't quite yet have schoolhouse type trainings or train the trainer type trainings, but that's certainly an area that we could explore if a customer was interested in that. Beyond that, we have a number of different warranty programs available to customers. So the basic warranty, I believe, is 1 year, could be 2 years. And then after that, we have a long duration warranty program that the customers can purchase that replace any damaged part for up to 10 years, I believe it is. So we would inspect the part. Obviously, you can't drive over it with a truck and then say, well, I need a replacement. Obvious user problems, we have to work through those. But any failure in the workmanship, craftsmanship, the build of the system, we would own and we would replace. Through our dealer network, we have parts available throughout the world that are closer to the area of operation than potentially our headquarters in Pennsylvania. But sometimes the parts that don't usually fail, you may have to have those parts drop shipped from Pennsylvania. And we run a very active shipping department. They can usually get parts to locations within a day or two. Some remote locations, it may take a little longer, obviously. Areas only accessible via boat, for example, may take a little longer.
Thank you.
Thanks.
Looked like Laura had a question.
Hi, Hunter. Thank you so much for your presentation. My name is Laura Dwyer. I work for NOAA. You talked about how the systems are operable as long as the water is wet and in areas where there is seagrass. What other design features has VideoRay developed to overcome operations in challenging environments?
Ooh, that's a tough one. So the company's been around 25 years. And we've moved through a number of different vehicle designs. In fact, the first vehicles were not much bigger than a basketball. And obviously we're underpowered, underthrust, under actuated, and ran into a lot of problems that really prevented customers from accomplishing their missions. We've found over time that about the right speed is about 4 knots. So we've been able to add on the thrusters and the power options to get the vehicles up to 4 knots to conduct the missions. We've found that the optical cameras, certain customers need the rounded housings so that they get the fisheye view out of the camera. So they have a very wide field of view on the cameras. And then other customers, they want a flat lens, if you will, a flat window, so that they can have very high resolution images without the distortions applied through that fisheye lens. Other than that, we've spent a tremendous amount of energy making the systems reliable and as many components as possible field replaceable, so that in the event of damage or failure, the customers can make those changes and get the vehicle back in the water at the site of operation. So that's really a critical component of our modular open system approach to these vehicles. Another aspect is the human-machine interface. The more simple we can make that, the easier it is for operators to use the vehicles. So we've spent a fair amount of time. We work with a company called GMT for the current control systems, and we inform them and have them talk with our customers all the time so they can update those interfaces and make it more usable to the customers. Furthermore, we're always looking for weight savings to make it easier to move the systems around. So any opportunity we get to reduce the overall system weight, the tether weight, even the operator control consoles, bring those weights down and make it easier to affect the logistics of moving these systems around the world is a win for everybody. That means I don't have to break my back when I'm carrying the cases to trade shows like this week. And it also means our customers are more comfortable when they're performing their operations.
I have a follow-on question because you brought that up. So if you are lightening the system, do you anticipate any additional issues of being able to like fly underwater? Like if it's not heavy enough, it's not going to be able to go into currents and will become less operable.
For sure. It's just like aircraft. You change the weight and balance, the total performance of the aircraft changes, just like in underwater. So we're working very closely with the buoyancy, the meta center, we call it, that center of buoyancy versus center of gravity, to ensure that the vehicle is stable. We're constantly updating our software, and we mentioned 6 degree of freedom software earlier. That 6 degree of freedom software can adaptively change the power curves for each of the thrusters so that you can operate in unusual poses and cross currents, if you will. So like you mentioned and suggested by your question, making one change, like losing a few pounds around the middle, affects all the other systems, software, hardware, performance. And we certainly are interested in unusual attitudes and unusual customer requests so that we can continue to make our control systems and vehicles more robust. So, thank you.
William, Bill?
Thanks, sir. As an aviator, you sort of alluded to this, that there's issues when they're on the surface wearing their virtual reality. Are there any specific visual illusions that you have noticed with UUV operators, the way that we notice them with pilots and actual aircraft?
No one's ever asked me about that before. It hasn't come up yet. I'd really be interested to learn more about what the experience is with the aviation, and then I could maybe have a target to look for the undersea. That's a really interesting question.
Thank you.
So we do have one more in the text chat, and then I think we're going to call it an evening and really express appreciation for Hunter's time. From Brenda, you expressed planning to eventually move to a mixed reality method of the operator surrounded by several screens. Are you looking towards the proximity of the operator not being on the deployment vehicle, not being on the nearest landmass, but the safety of the operator, access to certain proprietary processes of your equipment, etc.?
There's a lot in that question. I'm going to try to unpack it. So right now, the idea with the mixed reality control is that an operator can be on the small vessel, on the large vessel, at the site of deployment, or they could be at a remote location. So that's very exciting to us. Obviously, that remote location teleoperation will be contingent upon the communication lag, the delays we have between it. So the faster the comms are, the better and easier that will be for the operator to conduct that mission. You can imagine trying to drive a car where when you turn the wheel, the car waits 3 seconds, 4 seconds, 5 seconds before it actually makes a change in its steering configuration. I can't imagine that anyone would enjoy that or be good at it without a lot of practice. So as far as intellectual property with our vehicles, to address that part of the question, we're not overly concerned because we make as much of the vehicle open access as possible, because we want our customers to have as much opportunity to interact with the vehicle in the ways they want to. So we make as much of our physical interfaces public, our electrical interfaces public, and our software API, application programming interface, public, so that the more advanced customers, if they want to write their own software for the vehicle, they have that opportunity. Did that answer the question?
Yes, it did. Thank you so much.
Excellent. Thank you.
Excellent. Well, on that, I would really like to thank everybody for joining us tonight, as well as a huge thank you to Hunter for sharing his thoughts and expertise regarding where we're heading with undersea maritime uncrewed systems. This has been just a tremendously informative session, and I hope it helps you all to better understand the challenges, capabilities, and even the opportunities that are associated with this technology. Students, for full credit, remember you need to add a brief discussion entry, just a single post by Sunday, No peer replies are needed, but I will encourage you to go ahead and engage in the discussion that's happening there. Just remember to identify you were in attendance and describe any new info that you weren't previously familiar with, and explain how your overall understanding of this topic has improved. I hope to have a recording of this session uploaded to the Instructor Corner in the next day or two in case you'd like to come back in and kind of re-review some of the detail. With that, I am going to stop the recording.
Great. And thank you all very